Okay, so in this center of gravity review question, we're looking at a 3-mass system, and 200 gram mass, and then two 100 gram masses, and they're on these massless rigid rods. I'm trying to figure out the coordinates of the center of gravity. These will be XY coordinates. So our equation for the X center of gravity would be multiplying x1 m1 plus x2 m2 and so on, divided by the total mass, whatever number of masses that you have in the system. So in this particular case, if we have the mass B is on the origin, mass C is 12 centimeters on its X position, it's 12 centimeters, and if we try to think about the where the location, X location, the 200 gram mass, hopefully you can see here, this is an isosceles triangle, so these two sides are the same. So if we were to figure out the X position, of course this would be equal to 6 centimeters from the 200 gram mass would have an X coordinate of 6 centimeters, and we'll figure out where the Y coordinate is later. So if we're thinking about the X center of gravity, and hopefully you can almost see that it's going to be 6 because of the symmetry in the problem. But just to prove that it is 6, we can go ahead with the calculation. So in B, we could have 100 grams times 0 centimeters for B. So you don't have to include that, but you could. But it's just going to be 0. Then you have got the 200 gram mass, 6 centimeter on the X, and then plus the 100 grams. I'll run out of room here again, times 12 centimeters. And you have to divide all that by the total mass, so 200 plus 100 is 300, plus 100 is 400. And what you should find here is that this is exactly equal to 6 centimeters. This just goes to 0. Yeah, so you have basically sort of 1200 gram centimeters plus another 1200 gram centimeters, that's 2400 gram centimeters divided by 400 grams, leave you with 6 centimeters. And then for the Y, you have to do a little bit of work to figure out what is the, so the Y coordinate of B and C is 0, but the Y coordinate of 200 is where a little bit of work needs to come in. So we know the base length of this here is 6 centimeters. And we're trying to figure out what's the Y coordinate of the 200 gram mass. So you may be able to recognize that this is certainly a scaled triangle of a 3, 4, 5 triangle. But if you wanted to find out the value of this Y here, of course we know, just again to be more thorough, you can say that Y squared plus 6 squared equals 10 squared. So Y would be equal to the square root of 100 minus 36, which is the square root of 64, so Y equals 8 centimeters. So again, you can see that this is sort of a scale triangle of a 3, 4, 5 right angle triangle. So to figure out what the Y coordinate of the center of mass, so YCG, we would have, these two have 0 and Y coordinate, so I could again multiply 100 times 0, but now I won't because it's just equal to 0. So I just have the 200 grams times 8 centimeters, all divided by the total mass, so you have to still include the total mass of 400 grams, and this gives us 4 centimeters. So our coordinates are XCG, YCG would be equal to 6 centimeters, 4 centimeters. So choice C.